All right, in this lesson we're going to look at something new, which is the Gauss-Jordan Method. We're going to solve systems of equations using the Gauss-Jordan Method. Now, the writing on this is a little small, but if you look at this, this is a matrix right here, and that's what we do with Gauss-Jordan Method. We convert our systems of equations into matrices, and we do row and column operations, and we'll get into that in a second. But this matrix right here, it says how many rows and columns does it have. I use RC Cola as a way to remember rows and columns. See, rows are always first, columns are always second. So it's RC Cola, it's not CR Cola. So your rows, here's my rows right here. This definitely has 2 rows. And then my columns, 1, 2, 3, 4, 5, 6, 7 columns. So the dimensions is a 2 by 7. This has 2 rows and 7 columns, RC Cola. If you look at this, there's elements like this 3 right here. This 3, that's in the second row and the third column. So that's in entry 2, 3 is what this is. In the second row and the third column. This is what this is asking for down here. What's the element in the second row and the first column here? Well, the second row means it's got to be down here in this row, and there is only 1 column, so that's going to be 5. All right, now what we do with this Gauss-Jordan method, we convert our systems of equations into what's called an augmented matrix. Augmented because you have your coefficients here, and you have a little line, and then over here you've got your solutions. So like right here, if I take this system to convert it to an augmented matrix, I'm going to have a -3 and a 4. I'm going to have a 9 and a 2. And over here, I'm going to have 2 and 5. And this is an augmented matrix. Okay? And what we do is we do row operations to convert this. Our ultimate goal is right here. We want to get an augmented matrix converted to look like this. Let's just make this up. This is not my answer, but we want to get 1s in the diagonals this way and 0s in my diagonals this way. And then when we do that, this is obviously the X column, this is the Y column, and so that means 1x is 5, and then right here this means 1y would be 7. So this obviously this is x and this is y, and it helps us figure out what the answers are. Like right here it's saying, by what number must the first row of the augmented matrix be multiplied so that when it's added to the second row, the element in the second row becomes 0. So what we're doing here is we want to get this to be a 0. So what I could do is I can multiply this by 2. And then 2 times -3 would be -6. 2 times 4 would be 8. 2 times 4 would be 8 again. And then I can add this to that row. 6 plus -6 would be 0. 2 plus 8 would be 10. 7 plus 8 would be 15. And now that converts this row into a 0, and I would replace that. So the first row must be multiplied by 2. Okay. On this one here, what's the augmented matrix for this system? Okay, so you can see here this would be 3, 2, and look, we must have z's in here, so there's no z. This would be 6. On this one here, we've got -6. Well, we have no y. That'd be a 4, and that's going to be a 1. And down here we have no x, and so my y would be -9, and my z would be 2, and then this would be 4. And that's how you write an augmented matrix. Okay. And so on this one here, by what number must the first row of the augmented matrix be multiplied so that when it's added to the second row, the element in the second row, first column, becomes 0? Okay, so this is similar to the previous one. If I take this times -3, I'm sorry, if I take this times 3, not negative 3, 3 times 2 would be 6, and then I could add it to that row, and it would make that be a 0. So 3 is what I would do. All right, so down here in this one, it wants us to use a specified row transformation to change this matrix. -4 times row 1 and add it to row 2. So if I take -4 times this row right here, -4 times 2 is -8, -4 times 3 is -12. And now I add this to this row 2 here. So 8 plus -8 would be 0. 5 plus -12 would be -7. So this would be 0 and -7. Okay, well, let's get into doing this. This is a little bit bigger print. Use Gauss-Jordan method to solve this following system of equations. Well, first we want to get our augmented matrix. So my augmented matrix is going to look like this. I've got two variables, so I've got 1x, 1y, and then I've got 6. And I've got 1x, and then I got minus 1y, so it'll just be -1 here, and then a 3. Oops. So here's my augmented matrix. Now, again, let me write it right here. I want to get 1, 0, and then whatever my answer is. And then I want 0, 1, and whatever my answer is there. Let's just say it's a 3 and that's a 2. And then that would tell me x would be 3 and y would be 2. This is what I want to get to. So I want to convert these to this by doing these row operations. Well, right here, I've already got a 1, so that's good. Now I need this one right here to be a 0. So usually when we do the Gauss-Jordan method, we start with this column and get those numbers in place, and then we shift to the next column and get those numbers in place, and then repeated columns, whatever. So I think what I'm just going to do is I'm going to write this one down here, and I'm just going to subtract it. Okay, so this row is going to stay the same. But now I'm going to subtract this one from that one, which means 1 minus 1 would be 0. -1 minus 1 would be -2. And then 3 minus 6 would be -3. All right, so here's where I'm at the first step, and I've got my column like I want it. So now I can shift over to the next column. All right, now usually we get our 1s locked in first. So like in this next column right here, I need my 1 right there. So it's this -2. I need -2 to be a 1. So what I'll do is I'll just divide this whole column by -2. Okay. All right, well, let's move this up a little bit. So when I do that now, so I'm going to go ahead and write my new row in here. So 0 divided by -2 would be 0. -2 divided by -2 would be 1. -3 divided by -2 would just be 1.5. And there you go, I got my 1 in there. And this whole bottom row is now what I want, because I've got my 0 and a 1. Now up here, I've got my 1. This needs to be a 0. All right, so what I'll do is, to get to be a 0, I need to add or subtract. And I'm going to take this row I already got. Since that's a 1, 1 minus 1 would be 0. So I'm going to take this row right here and subtract it from this one. So I'm going to do 1 minus 0, which is 1. I'm going to take this 1 minus this 1, which is 0. And then I'm going to do 6 minus 1.5, which is 4.5. And there you go, we're done. We've got our matrix like we need. And then here's my answers. X is 4.5, Y is 1.5, and these are my solutions. Okay. Now here's another one, maybe a little more difficult. All right, so my augmented matrix, 2, 3, 29, 5, negative 2, and 6. There's my augmented matrix. All right, well, ones we get in place first, and just let me remind you here, I want 1, 0, and whatever this comes out to be, say 4, and 0, 1, and let's say it comes out to be 3, I don't know. But here's what I want to get to. I want to get my augmented matrix to have this on the left, and then there would be my answers over here on the right. Okay, so first thing I do is I start this first row, and I got to get my 1 in place first. So right here, this is a 2. So what I'm going to do is I'm going to divide everything by 2. 2 divided by 2 is 1. 3 divided by 2 is 1.5. 29 divided by 2 is, what's that, 14.5. There you go. Okay. Now down here, I need this to be a 0. All right, so what I'm going to do is on this row here, that's a 5. Well, I need to subtract 5. 5 minus 5 would be 0. So what I'll do then is I'm going to take this row here, I've already got locked in place, and I'm going to times it by 5. And what I'm going to do is I'm just going to times it by negative 5. That way that's negative 5 times 1 would be negative 5, and then I can just add my rows together. So negative 5 times 1 is negative 5. Negative 5 times 1.5 is negative 7.5. Negative 5 times 14.5 is, let's see here, I don't want to make a mistake. Negative 72.5. So I did negative 5 times this row. Now I'll add these two together, which 5 plus negative 5 is 0, and that's what I want. Now negative 2 plus negative 7.5 is negative 9.5. And then 6 plus negative 72.5 is negative 66.5. And there you go. My first column looks great. That's what I want. So now I can shift to this second column. And of course, a reminder over here, I want my second column to look like this. All right, well, the ones you got to do first. So right here, I need to get this to be 1. Well, I just divide by negative 9.5. All right. Okay. All right, so 0, oh, I got to divide that by negative 9.5 too. 0 divided by negative 9.5 is 0. Negative 9.5 divided by negative 9.5 is 1. And then negative 66.5 divided by negative 9.5 is 7. All right, now I've got this row completely done because I got my 0 and my 1. And I can already see 7 is what y is. So I know 7 is the solution for y. Now I'm going to come up here, and I need this number right here. See, I need this to be a 0. So what I'm going to do is I'm going to have to add a negative 1.5 to this. All right, so what I'll do is I'll just take this row down here, and I'll multiply. Erase this off. I'm going to multiply this row by negative 1.5. Okay. So negative 1.5 times 0 is 0. Negative 1.5 times 1 is negative 1.5. Negative 1.5 times 7 is negative 10.5. And now I'm going to take this right here, and I'm going to add it to this one right here, and that should finish me up. So 1 plus 0 is 1. 1.5 plus negative 1.5 is 0. And then 14.5 plus negative 10.5 is 4. And there you go. I've got what I want right here. Actually, this is called the identity matrix. And over here, x is 4, y is 7. So 4, 7 is my solution. Okay, so on this one, we want to solve this one. I need to make my augmented matrix for it. Now what I'm doing here on this one, I noticed that this is 25. I'm going to divide everything by 25 to make that be a 1. And that's going to make this kind of sloppy. I think 10 might divide better. So what I'm going to do is I'm just going to switch them. So I'm just going to put, there you go. And I'll just use these in my augmented matrix. So it's going to be 10, 1, and 8, negative 25, negative 3, negative 19. And that might make it work out a little bit better. All right, so again, let me put a reminder over here. I want 1, 0, 0, 1, and 5, 2, whatever it comes out. Could be negative 2, I don't know. But this is what I want. Okay. All right, so to get my 1 in place, I'm going to divide everything by 10. 10 divided by 10 would be 1. 1 divided by 10 would be 0.1. 8 divided by 10 is 0.8. All right, and there you go. I got my 1 in place. Now I need this right here to be a 0. So what I need here, 25, I need to add 25 to this to get a 0. So what I'm doing is I'm going to take this row I got locked in, I'm going to multiply it by 25. 25 times 1 is 25. 25 times 0.1 is 2.5. And 25 times 0.8 would be 20. And now add these together. So negative 25 plus 25 is a 0. Negative 3 plus 2.5 is negative 0.5. And negative 19 plus 20 would be 1. And there you go, man. First column's good. First column's good. Now I'm going to shift to the second column. Well, I got to get my 1 in place first. So right here, I got a negative 0.5, which means I'm just going to divide everything by negative 0.5. Okay, so continue on down here. Let's move up some. Okay. So 0 divided by negative 0.5 is 0. Negative 0.5 divided by negative 0.5 is 1. And then 1 divided by negative 0.5 would be negative 2. And there you go. Got my 1 in place, and I can already see y is negative 2. Oh, I was right on my guess there, wasn't I? All right, now, on this top row, I need to get my top row in. Well, my top row right here, I got the 1, but this needs to be a 0. So what I need to add to this is a negative 0.1. So I'll come down here, negative 0.1, and I'm going to times this whole row by negative 0.1. Negative 0.1 times 0 is 0. Negative 0.1 times 1 is negative 0.1. And negative 0.1 times negative 2 would be positive 0.2. And I will take this, and I'm going to add it to my row here. 1 plus 0 is 1. 0.1 plus negative 0.1 is 0. And then 0.8 plus 0.2 is 1. And there you go. I'm finished. I got my identity matrix, and here's my solutions. X is 1, y is negative 2. That's my solution, which I was off on the X. I got the y right, huh? Anyway. All right, last one we're going to do today. We've got 3 variables. All right, so now 3 variables is going to be a little bit more work involved, but it's not that much. Not difficult. Anyway, I've got a 1, and I got a negative 1, and I got a z column, which I have a 0 here in that equation, and a 3 over here. All right, down here I have no x. All right, I'd have a 1y, oops, and I have a negative 1z, and then this is a 2. Then down here I got a 1x, I've got 0y, and I've got 1z, and that's a 1. All right, so there's my augmented matrix. Now this time, let me put a reminder over here. I want this, 1 0 0 0 1 0, 0, 0, 1. And I want my solutions. Let's make a guess here. Let's say this is 4, 2, and -1. This is what I want to get, something like this. Now, I don't know about these solutions being right. We'll find out here in a minute. All right, so in this first row, we start off, I need a 1, 0, 0, and I'm going to do this column here. I've already got a 1 there, so I'm good there, man. I'm 1, -1, 0, 3, and actually, I need a 0 here. I've already got that one, so I'm going to go ahead and bring it on over. But right here, I need a 0 there. So I need to add a -1 to it. So what I'll do is I'll just do -1 times this row here. Let's do it down here. -1 times this row, and I'm going to add it to that row. So -1 times 1 is -1. -1 times -1 would be 1. -1 times 0 is -1. -1 times 3 is -3. And I'll add these two together. 1 plus -1 is 0. 0 plus 1 is 1. 1 plus -1 is 0. 1 plus -3 is -2. And there you go. My first column's good. So I'm going to shift to the next column. Well, now, in the next column, look at my reminder up here. In this next column here, my 1s I do first. And so this 1 right here, well, look, it's already 1. So we don't have any work for that one. So I'm going to go ahead and write her in. I got a 0, 1, -1. Now, notice how I'm putting it in the middle. Okay. Now, right here, I got to have a 0, and right there, I got to have a 0. So up in this top one, let's get it in first. This should be a 0 here. So what do I add to -1 to get a 0? I got to add 1. Well, look, that's what this is. So I'm just going to go ahead and add these two rows right here together. So here, let me circle it. This row and this row right here. So 1 plus 0 would be 1. -1 plus 1 would be 0. 0 plus -1 is -1. And 3 plus 2 is 5. And there you go, got my 0 in. Okay. Now down here, I need this to be a 0. See here, I need it to be a 0. Currently, it's a 1. So what I'm going to do is I'm going to take my 1 row that I did already. I'm going to multiply it by -1. -1 times 0 is 0. -1 times 1 is -1. -1 times -1 is 1. -1 times 2 is -2. And now I'm going to add these two right here together. So 0 plus 0 is still 0. 1 plus -1 is 0. There we go, that's what we wanted. 0 plus 1 is 1. And then -2 plus -2 is -4. And there you go. Both our first two columns are perfect. Just like we need them. Okay. Now I got to get this last row. You always do your 1 first. So I need to get this 1 right here locked in first. So right here, this needs to be a 1. It already is. So that wasn't too bad. I'll go ahead and write that down. Okay, now these two right here have to be 0s. Well, they're both -1, and this is a 1, so I'm just going to add this row to both of them. So we'll do this top one first. I'll add these together. I don't have to do any multiplying or anything because these are already opposites. So I'll add these together. 1 plus 0 is 1. 0 plus 0 is 0. -1 plus 1 is 0. And then 5 plus -4 is 1. Okay. And there you go. Now in the middle here, I'm going to add it to this one because it's a 1 and -1, which makes 0. So 0 plus 0 is 0. 1 plus 0 is 1. -1 plus 1 is 0. 2 plus -4 is -2. And there you go. I've got my identity matrix, and here's my solutions over there. X is 1, Y is -2, and Z is -4. Well, you know what? Look here, man. I did some good guessing. My numbers were the same numbers, but didn't have the signs right and didn't have them in place right. But anyway, this is how you do Gauss-Jordan method. So if you have any questions, just let me know. Have a great day.